It's a cosmic riddle scientists are still trying to solve, showing us there's always more to learn about our universe's origins. One quirky detail is that these early collisions weren't always violent. Sometimes they were more like cosmic high fives, slow enough for the particles to merge rather than break apart. It's truly amazing to think that the building blocks of Earth started with such delicate interactions. However, a significant academic tension remains. How exactly did these planetesimals grow from meter-sized boulders to kilometer-sized bodies so quickly? Current models suggest they should have either spiraled into the sun due to gas drag or shattered upon collision, a perplexing conundrum known as the meter-size barrier. Thanks to electrostatic forces, a bit like static cling on laundry day but on a cosmic scale, these tiny particles don't just bounce off, they actually stick. Over thousands of years, these microscopic specks grow into pebbles, then boulders, then small asteroids. It's like a cosmic demolition derby happening in super slow motion, where every collision, instead of shattering things, mostly leads to growth. This gentle dance eventually culminates in kilometer-sized bodies known as planetesimals. This gradual buildup from microscopic dust to these foundational blocks of planets is a key scientific fact of planetary formation. As the swirling cosmic cloud began to flatten and organize, a process we briefly touched upon earlier, you're now inside what scientists call the protoplanetary disk, a vast rotating platter of gas and dust orbiting our very young sun. Think of it as a galactic construction zone, brimming with the raw materials for future worlds. Here, the primary principle at play is accretion, a fancy word for small particles slowly but surely sticking together to form larger ones. Imagine countless dust grains, each no bigger than a speck of glitter, gently bumping into each other. Think of it as the sun taking a massive cosmic broom and sweeping its immediate neighborhood clean, leaving behind the heavier, rocky materials that would eventually form planets like Earth and Mars. This turbulent early phase was crucial. Scientists still debate the exact timescale of this clearing out process and how it influenced the final composition of the terrestrial planets, like Earth, shaping them into the worlds we know today. Our star, the Sun, is born, blazing to life like a cosmic matchstrike. But the Sun wasn't content to just sit there and shine. In its infancy, it was a temperamental youngster. A compelling detail you might not often consider is the solar wind, which wasn't just a gentle breeze back then. This was a powerful, violent stream of charged particles erupting from the new star, blasting away the lighter gas and dust from the inner solar system with incredible force. It's like an invisible hand squeezing a giant sponge, but with the force of billions of Earths. As the matter squeezes tighter and tighter, the pressure becomes unimaginable, and the core heats up dramatically, soaring to millions of degrees. It's not just getting warm, it's becoming an inferno. Then the magic happens, the key scientific event of this section. Nuclear fusion ignites. Hydrogen atoms, under that extreme pressure and heat, are forced together with such incredible power that they fuse, creating helium and releasing a colossal burst of energy. Voila! Now, let's cast our gaze further out into the cosmos, to a time billions of years ago, when our very own star, the Sun, was just a glimmer in the universe's eye. Imagine yourself floating within a colossal cloud of gas and dust, a stellar nursery, vast and dark. You're witnessing the first act of creation for our solar system. Deep within this nebula, gravity, the universe's ultimate sculptor, begins its relentless work. The densest core of this cloud, an incredibly massive clump of hydrogen and helium, starts to compress. Over millions of years, these tiny specks will grow from dust to pebbles, then boulders, then planetesimals, the very seeds of a new solar system. You are at point zero, the moment before creation, about to witness the chaotic and spectacular birth of the planet we call home. How does a world form from mere dust? What violent trials must it endure to become a cradle for life? Our journey begins now. It's not a fast or violent process, at least not yet. Instead, it's a patient, persistent gathering, like tiny electrostatic charges pulling lint from your clothes, but on an unimaginable cosmic scale. It's a bit of a quirky detail, but initially, it's not raw gravity doing all the work. It's more like static cling, helping those first tiny particles become friends. Scientists still debate the exact mechanisms that allowed these tiny specks to stick together so efficiently in the earliest stages, before gravity truly took over as the dominant attractive force. Instead, you are inside a vast swirling nebula, a cosmic cloud of gas and dust, a gigantic celestial construction site left over from the death of an ancient colossal star. Think of it like a cosmic aftermath, full of raw potential and enough material to build. Well, everything. Gravity, the universe's quiet, persistent architect, is already subtly at work. You watch, mesmerized, as microscopic dust grains, rich with elements like carbon, iron, and silicon, the very ingredients for everything, including you, begin to gently, almost magically, clump together. If you enjoy content like this, don't forget to like and subscribe. It really helps the channel grow. And hey, comment below where you're watching from, or tell us which natural mystery fascinates you most. Maybe it'll be our next adventure. Let's dive in and explore how it all unfolds. You find yourself floating, suspended in the cold, dark void of space. But this isn't the familiar, organized cosmos you know. It's 4.6 billion years ago, and there is no Earth, no sun, not as we know them. Welcome to today's deep dive. Have you ever looked up at the night sky and wondered where it all came from? Or perhaps, more specifically, how our incredible planet came to be? If you think building a house from the ground up is complicated, wait until you hear about what it took to forge an entire world from nothing but stardust. Forget blueprints and power tools. We're talking cosmic dust, unimaginable timescales, and literally a whole lot of chaotic, glorious banging together. It's the ultimate origin story, starring a truly unlikely hero, our Earth.